let us cover the first method where we first get an access of an handle and then use the value property. So we proceed like this. In the test bench code, we have our decorator and we will be adding a single test case, which is test. We have declared one temporary variable. Let it just name this as a value. So here we need to get an access of an handle. All the input and output port of a DUT could be accessed with the DUT dot, then we need to specify input and output port. So for us, the first input port is A. We'll be just adding an A over here. So this is how you get an access of an handle. Once you get an access of an handle, now you simply need to use the value property to apply a value to a DUT. So we proceed like this. For us, an handle is in A underscore val. To get an access of a value property, we use dot operator, specify the method as value equals to, let us add 4-bit value as 12. So this is how we access the input port in the first method. We first get an access of an handle and then use a value property. So this is how you get an access of an handle and then use the value property to apply the value to a duty. Likewise, we have another input port which is B. For this, we add the temporary variable to get an access of an handle. So it will be duty dot B. Then to apply a new value, we will simply be calling a value method and apply the random value. Let it just add 15 to it. So these are the two values that we have applied to a duty. And to demonstrate this, let it just go ahead and try to execute our code. So we first save all the file, test bench file, design file, as well as an make file, because we have did modification in all of this file. Now we proceed and call make sim equals to Icarus. First thing that we need to get is the test pass. So once we get the test pass over here, now we have our data of a waveform stored in a dump.vcd file. So we need to make sure that we have stored our data in an VCD file. Here we haven't dumped our waveform data in any of a file. Hence, we won't be able to analyze values on the input and output port. So we proceed and we add this two statement: initial, begin and end, dump file. Here we will be specifying the file name, which will be dump.vcd, then semicolon, and then we add dump wars 1 to include all the variable values of our module adder, and then we need to specify module name itself, which is adder. With this modification, now once we execute our test bench code, we'll have the waveform data for all the signal in the dump.vcd file, which we could use in a GTK wave to analyze the waveform. So with this modification, now we are ready to again execute our code. We need to make sure that we again get test pass. So once we have our test pass, now our data will be stored in dump.vcd file. So let it just call gtk wave and specify the file name where we have our waveform data. So once our gtk wave is open, now we'll select our object adder, which consists of all the input and output port. Select all the input and output port and click insert. Now if we analyze on a gtk wave, we get high impedance for A and B, which is the default value for a wire type. And then for Y, we are getting undefined. Probable reason might be that we haven't executed the simulation for enough time to get the data. So to do this, we could add the delay to keep our data stable for a few nanoseconds before we actually have valid output also, right? So here we wish to add the random delay. And to do this, we do have the libraries in a COCOTB. So in the COCOTB, if you analyze, we have a triggers. These have the methods to add the delay in a code. If you go to the triggers, so here we have our timer class. So this allows us to wait for a specific time to get the delay. Now this do have certain argument. For example, first argument is the time for which we wish to wait. The second is the unit of a time. So it could either be the picosecond, nanosecond, microsecond, or a millisecond. And then the round mode. Okay, so the typical usage of timer will be something like this. Await, specify the timer, specify the time for which you wish to wait, and then the unit. Let us proceed and try to add this in our code to apply this value for 10 nanoseconds. So first we need to import the timer. This is present in COCODB. So if you analyze, this is present in triggers of a COCOTB. So we proceed like this from COCOTB dot triggers import timer. So once you import a timer, you are allowed to use the methods of a timer. To wait for a specific time, we have a wait method. Then we need to add a timer, specify the time for which we wish to wait, which is 10 nanosecond in our case, and then the unit of a time, which will be nanosecond in our case, right? With this modification, now we have our stimuli applied for the 10 nanosecond, and this will be enough to get the valid out. Let us proceed and try to execute the code again. First, we need to close our GTK wave. Then we just need to call make sim equals to Icarus. In fact, you could press up and down arrow to get the command that you have already added on a terminal. So here we get again a test pass. Let it just click on up arrow to get the previous command, which is gtk wave dump.pcd. We again select our adder object, select all the input and output port, and then we click insert. Now you could see we get valid values on A, B, and S. And if we just click on the value, so we get C and F. Let us just try to change radix of all of this. So we'll select all of the ports, right click, and data format will be decimal. So 12 plus 15 will give us 27. So this clearly suggests us that we able to apply the random value to a duty with the help of the first method. So what we did over here, we have taken the axis of an handle. This could be done by using a dot operator and specifying the name of the port. To get an access of an input port A, we have used DUT.A, and then we need to use the value method to apply the value to a DUT. We have also imported the timer from a COCODB trigger to wait for random delay.